Campus, student number 22003150, and this is my practical robot for module ELB 1502-2025, where the objective is to build a firefighting robot which senses open flames and navigates itself autonomously to extinguish the flame. Let me give you an overview of the components used. First, we start off with the Arduino board used as the microcontroller. At the back we have the L298N motor driver used to control speed and direction of the wheels. Then next to it we have a relay used to power up the DC motor of the fan, and on the other end at the back we have a buzzer. In front we have two power sources, two 9 volts here in the center, which one source is dedicated for the motor, so it will be the drive wheels as well as the fan motor, and then the other power source will be used for sensors and encoders. That's right, I have encoder fitted to motor A right at the bottom underneath, and then we have a flame sensor mounted in front. The source also activates the relay as well as the buzzer, and then we have a red LED that is for fire detection or fire has been detected, and then we have a green LED which indicates that the Arduino is powered. The reason for mounting the Arduino on top is for easy programming and wiring. I try to make the design as symmetrical as possible and hide as much wires as I can. So I will demonstrate to you shortly how the robot activates. It does move autonomously towards a flame. It scans the area for any other open flames, so there will be 2 tests conducted. It does meet the practical criteria which will be demonstrated, and then more details of troubleshooting and how I solve these problems will be in the portfolio document. Thank you. Okay, I will demonstrate to you how the robot operates, just to give you a quick overview on what to expect. I will create a fire on the one side, I will place the robot on the other side of the room. The robot would initiate a 360-degree scan of the area while monitoring for any flames via flame detection sensor. So once a flame has been detected, the scan should terminate and the buzzer as well as the fire detected LED should come on. The robot would then attempt to move towards target, but if the target is lost during the process, the robot will do a 120-degree scan to the one side and a 240-degree scan towards the other side, so that the target can be found. If the target is found during the scanning process, the scan will terminate again and the robot would move forward until it meets its second threshold, which would activate the fan and try and extinguish the fire. If the fire is not extinguished quick enough and the robot is moving forward, once it meets its third threshold, the drive motor should halt and the fan will continue running until the fire is extinguished or the threat is eliminated. Once the threat is eliminated, the robot would do a scan of the environment again, so at which point I would create a second fire to demonstrate autonomous movement of the robot for a second time. Okay, so I'll start by igniting the flame. Okay. It's my matchstick. Which way I will power on the robot. To a second flame, it will scan the area. To a second Okay. Here we go. I've demonstrated what the robot can do: scan, detect, approach, and extinguish. Everything in a nutshell. I've not only built the robot, but I've built a deeper understanding for problem solving, how sensors and microcontrollers can be integrated to build almost anything if you have the perseverance and put your mind towards it. I just want to thank you for watching this video. Take care.
Fresh out the house, got the beat on suicide as I ride up and down Martin Luther King Drive. Standing tall, looking down on the